All right. One of the last major wrinkles, complications in ion compounds, and that is polyatomic ions. So these are a group of atoms that are joined together by electron pair sharing, like covalent molecules, except that they have a net positive or a net negative charge. And what you need to know at this point is that you just treat them as one thing, one separate entity that doesn't really break apart unless you're told something is happening to it. Give you a couple of examples. Very common one here is this NH4+. This is called the ammonium cation, so these things have their own names. And it has a formula of NH4+. If it's drawn like this, so let's go back to Vesper here. So this is a bunch of hydrogens that are tetrahedrally arranged around a nitrogen atom. And the thing overall has a positive 1 charge. The reason why we write it with just a bracket and a plus sign kind of away from it is to indicate that the positive charge isn't necessarily on one spot or one atom. It's kind of distributed over the whole thing. Now there are also negative polyatomic ions or polyatomic anions. An example of this one is nitrate. So this is a common component of agricultural runoff. So nitrates are used in fertilizers a lot. And so if you put a lot of it in the fields and the rain washes it out, and it kind of starts to accumulate in the streams and the rivers and all that stuff. Its formula is NO3 with an overall negative charge, so the formula is NO3 minus, and again we can write it with this little bracket negative charge right there. Now the bad news is that there are a lot of these and you need to know a subset of them. The good news is the subset is not huge, so here it is. Now this is also reproduced. I'm going to post the slides for this presentation without the narration because it's a smaller size. And I also have a handout that shows you a little bit about this, and this chart is on all of them. These are the ones I'm going to expect you to know. And let me point out a couple of things. There is a series, right? So if you look at some of these are different combinations of the same 2 elements. Like here, chlorine and oxygen. So I've got 4 chlorine oxygen compounds here. And I've got 2 sulfur oxygen compounds, and I've got 3 phosphorus oxygen compounds here. And they do form a pattern. I want to talk about that a little bit on the next slide. But the thing is that you're going to need to be able to recognize these. You're going to need to be able to recognize the formula, including the charge, magnitude, and sign, and its name. Now this is only about 20 or so. It's not that bad. It's a very small list. But these are the ones that you'll be expected to know. I don't like to use the word memorize a lot. This is actually one of the few times that I do. But the quicker you memorize these, the quicker you're not going to have to keep looking at the sheet, and you'll be able to work faster and move on. So I want to point out some similarities. Like you'll notice how these guys right here, SO4 2 minus and SO3 minus, they have similar names. So be careful with this. This is sulfate. This is sulfite. Now they happen to have the same charge, in this case -2. Where they differ is how many oxygen atoms are involved. Same thing for phosphate and phosphite. And I'll go back to my friend chlorine here. I've got 4 chlorine oxygen compounds that also happen to have this ate and ite suffixes at the end. And that is important. I want to show you what those words mean and how you can use that to help you out. What I do want you to look at, so let's look at these formulas here. You will note that ate versus ite does not respond to a particular number of oxygen atoms. So for example, with phosphate, you've got 4 oxygen atoms, and in phosphite, you've got 3. as opposed to, now sulfate seems to have a similar pattern, right? That it's got the sulfate has 4 oxygen atoms and sulfite has 3, but you don't see that trend everywhere because chlorate, in this case, has 3 oxygen atoms and chlorite has 2. And, oh, I forgot about nitrogen. Let's look at these guys too. Nitrate has 3 and nitrite has 2. So it's not consistent that the ate form refers to a certain number of oxygen atoms and the ite form refers to a certain number of oxygen atoms. But what is consistent, because, well, they're different for these 4 elements, but what is consistent is that the ate form always contains 1 more oxygen than the ite form. So in the case of chlorine, ate has 3, ite has 2. In the case of, nitrogen, nitrate 3, nitrite 2. And in the case of sulfate, sulfur, sulfate 4, sulfite 3, and phosphorus, phosphate 4, and phosphite 3. So what it does tell you is the relative numbering of these things, but not the absolute. But so you know that regardless of the element, the ate form will always have 1 more oxygen atom in the ite form. Now there are actually 4 rankings of this, and I'm going to bust out a new slide and show you what all 4 of them are, using the chlorine as an example. All right. So here we're going to be working with ate, ite, and more. So when I'm going to use one of the chlorines. So this is kind of starting in the middle of the sequence, but between these two, ClO2 has the fewest number of oxygen atoms. So this is going to be the chlorite anion. And ClO3 has 1 more. And so that's going to be the chlorate anion. So what do you do in cases like chlorine where there are more than 2 combinations with oxygen? So for example, if there is, let's talk about the species ClO minus. So this has 1 fewer oxygen in the IgE form. So think about, if you want to figure out how this works. This is, it stays chlorite, but now it adopts a prefix, which is hypo. Now, if you want to kind of figure out to remember that prefix hypo, think about getting a shot and what the actual name for that device is. It is a hypodermic needle. Hypodermic means under the skin, which is, these things are meant to inject something under your skin. So 1 oxygen less than the ite form is the hypo something ite. And if you have 1 more than the ate form, ClO4 minus, right? So the opposite of the prefix hypo is hyper. So hypo means below, hyper means above. But we don't use the full hyper. I don't know why, but we do use the last syllable, per, and then chlorate. Now again, they all have the CHLOR root. If there are only 2 forms, ite has fewer oxygens than ate. If they are 4, they adopt this range. And so, in case you're wondering, this, by the way, is the active ingredient in liquid bleach. And this, when I was talking about the space shuttle a couple slides ago, this is one of the components a solid rocket fuel. And chlorite also is a little less reactive than the chlorate, and is often used in fireworks. All right. So this is how you name a series of multiple ions that are combinations of the same element. All right, so again, remember, the atoms in the polyatomic ion should be treated as one single unit. And we show that by actually grouping them together with parentheses. So for example, the combination of the zinc ion, which is reliably +2, and the nitrate ion, which is -1. So they're going to react in a ratio that is 1 zinc to 2 nitrates. And we write the formula like this, indicating that this actually is 2 nitrate ions, as opposed to some other grouping of 2 nitrogen atoms and 6 oxygen atoms, which could be a completely different molecule. But when you see them grouped together like this, that's a sign that what's inside is a polyatomic ion. And it is 2 NO3- units, and not just some random combination of 2 nitrogens and 6 oxygens. Okay. So you might think that, oh, I just have to look for parentheses, and that's how I can spot a polyatomic ion. And that will tell me that it is an ionic compound. But the issue is that we don't do that if there's only one of them, because it's not necessary. And scientists are lazy and don't want to write any single character that is not absolutely necessary. For example, calcium and sulfate. So this is a thing called gypsum, and it is a main component of the white sands at White Sands National Monument. And since they react in a 1-to-1 ratio because they are +2, -2 pair, so the formula is simply just CaSO4. So you will need to still know that SO4 is one of those polyatomic ions you are supposed to know, and then paired with calcium.